So what recommendations would the panel have going forward in developing energy optimization programs within their sites? What do you think a program would look like where there's long-term sustainability and the use of technology and sound work processes? Can you talk about that?
Well, I guess I'd say first there's some choices. I mean, as we, not to oversimplify the problem, but as we look at our customer base, there are customers that are perfectly happy to outsource a lot of this kind of stuff. And there are others that are sort of aiming to be self-sufficient. So I think that's the first question you have to answer is what kind of an organization do you want to be and what's the role of the vendor community within that model? And from there, then I think it's a matter of putting together the information that you believe that the skill sets that people are going to need and find ways to address the gaps. And as a vendor, I can tell you that when I look at my services business today versus where it was a decade ago, it's somewhat of a regional problem, but in general, we are finding that clients that are just beginning to climb that curve, that is I'm talking about outside of the core APC consumers of refining and olefins and that, and getting into spec and some of the smaller type process units that coming up that curve, they expect our services ability to change from simply sort of expert gun for hire and take on more of a teach me to fish kind of a capability. So I think that's one way to sort of address it, a stronger relationship with your sort of trusted advisor vendors to figure out first what kind of a company do you want to be. Does your culture is more tuned to you having that expertise in-house versus outsource? And if you're going to be self-sufficient, then you need to think about the skill sets and the growing workforce problem and put together a sustainable educational component to the way you run your organization. And I think that's really the only way to sort of address the problem. So.
Any other comments from the panel and recommendations to go forward?
I would add a little bit to that. I mean, first, I would add that just about every plant I've ever been in has opportunity to save energy. So, I mean, the opportunity is everywhere out there. So I would start there and say, if you look closely enough, you're going to find the opportunities out there. The second thing that I think is really critical to getting an effort going is make sure you establish a champion within the plant or within the company who is going to be able to carry this program forward to help get funding and help sustain it and help roll it out across multiple plants if you have multiple plants and so on. So having a champion established is one of those kind of key factors for success. Otherwise, the program will, eventually fall apart. The third thing is there needs to be an intervention, if you will. We kind of need to step in and say, hey, we need to change the way we're doing things. We wouldn't have all these opportunities, if we were doing everything the best way possible. And that sometimes has to shake up at least part of the organization in terms of how they perceive what their job is, what it is that they measure in terms of how they know they're doing a good job or not. But you need to intervene, and then you need to be able to continuously monitor and sustain the performance over time. So don't just intervene and then walk away, but recognize that process plants are dynamic places. There's always changes going on. Summer to winter even is a big change for a lot of plants. So to sustain performance, you really need to continuously monitor performance, keep an eye on it, and flag new issues as they arise.
So we've talked a little bit about the use of analytics and easy data mining and accurate data coming from historians and the use of simulation and model predictive control technologies. They seem to be in pretty widespread use. So there's lots of new technologies coming down the pipe in terms of everything from cloud computing to mobility and advanced analytics and operator advisory systems. Does anybody have an opinion on where you think technology is going?
Wow.
I guess I'll try to kick it off. As I've been around the controls business for a couple of decades, I'll go back to some of the comments that were made about the use of simulation. And simulation is an incredibly powerful tool. And yet what we find is that from a technology adoption standpoint, there are a lot of internal silos in our customers' companies. And so I think that one of the trends that I'm beginning to see is a closer collaboration between the simulation experts and, let's say, the control experts. And it's coming to bear in some unanticipated ways. Back to the very first question that was posed of how do you justify projects. And there's really two things you have to do. You have to sort of do all of the technology assessment and all of the economics and deal with all of that. But then ultimately you have to deal with, human emotion. You have to address operators' concerns and plant managers' concerns. So one of the things that we're seeing is that we now have the ability to take a controller block and put it into a simulation flow sheet. And in this way, we can sit down with plant managers and with operators and show them, when you have this kind of a disturbance, this is what the control system is going to do, and this is how it's going to impact the operation of the plant. Now, that's a fast track to getting sort of the emotional buy-in. And to the degree with which you have the appropriate fidelity in that simulation model, then you also now have a bootstrap technique to get on side with the economic argument as well. So, I think that's one of the trends is there's been a lot of success in sort of the discrete use of these technologies within the operating companies, but what we're seeing now is sort of a smearing of the skills and synergy, if you will, between some of the technologies such as simulation and control and advanced analytics. Yes, sir.
Well, two trips, but well below that. Yeah.
So this way, simulator is good for operator training, it's good for startup, but simulating controllers or tuning and so on. Personally, I work for ExxonMobil and didn't see that the value.
One thing that's worth pointing out too is a lot of these software packages out there, it's not like a full-blown simulator from a loop tuning standpoint, but they have built-in tools that give you a predictive response. You can make it less aggressive, more aggressive. You see the response, and it's not a full-blown simulation. But that's just an example from a loop tuning standpoint.
Yeah, but when you're talking about energy savings, you have to do minimum whatever day for fall. Just choosing a couple of controllers will not bring you such a much value. You should really look at things in a holistic way to push profitable boilers versus non-profitable boilers and so on. And the most big value for energy is discrete control that really you guys didn't talk about. Like turning on and off the boilers, or you have to tell the boilers of the low throughput and so on. And that's a comment I want to make, at least for the United States, energy is so cheap when we compare the projects versus margin projects, usually all of the drop in the bottom. So I don't know if it's a value proposition, energy savings, or it's just a political solution. At least for the United States.
Well, I'll comment on the last one. That we just did a project in the United States at a site with very cheap fuel gas, and the savings on a steam multiple predictive control DMC application was quite substantial. It was not in the millions of dollars, but payback was at least still within a month or month and a half. It's a big complex. That's right. That's correct. But still, it's still attractive from an economic standpoint, but also from an energy standpoint. Many boilers, almost the whole plant, to put the
starting to grow.
George, did you have something to add?
Well, I'd like to add something to the question about the technologies, kind of where we're going in the future. I see three major things that have happened or that are happening that will drive this forward in the future. The first is, we used to dream about having massive computer power available to us, right? Now we have it. We carry it in our pockets. We have massive amounts of computing power available to us. That enables us to do some things that we never could have dreamed of before, doing things like analyzing all of the interactions between everything in the entire plant all of the time. I mean, that's a massive computing power kind of a problem that, we used to say, well, that would take a couple of Cray computers to do the job. Today we can do it, with a standard off-the-shelf Windows server kind of tool. So massive computing power, I think, is going to continue to change what's going on. We have massive amounts of data. Now we need to crunch through that data, and we have the power to do it. But to do that, we need a second piece, and that's what I call automated expertise. All of us in this room have some expertise from doing our jobs, and there's some real simple rules of thumb that we've used, and there's some that are much more complex. How to recognize certain types of problems, how to identify what to do about them, how to tell the difference between a big problem and a little problem. We carry that knowledge in our heads, and a lot of that can be automated. And as we are continuing to deal with an aging workforce and trying to find replacements in a younger workforce, trying to have people do more and more and more with less and less and less, we need to find ways to capture that knowledge and build it into some tools so that we can direct maybe some younger, less experienced people to get maybe not exactly the same but similar results to somebody that had that expertise built in before. So automated expertise, I think, is the next wave, and it's a big wave that's coming, and I think it's about to hit our industry in a big way. And then the third piece you touched on briefly is delivery of the information, and that's just going to continue to get faster and faster and better and more portable. And I think we're just going to continue to see that drive. So taking the massive computing power analysis, applying some real world rules, and based on the expertise, not just of vendors, but also of the expertise that lies within your own companies, and delivering it out to people where they're doing their job, where they're making the decisions. I think those are the three big trends that we see coming for the future.
It's been really exciting for me in my career because the technology explosion, it just continues, and it's exciting, but also a little challenging sometimes to find ways to keep up with it. There's so many things in so many different directions, from software to hardware, different components. These guys are doing this and that, so that's a challenge to find time to make part of your weekly things that I try to do is to. What's been announced this week? What's going on this week? What can I keep up with? What can I learn? That would be my thing. Just from it's just to make that comment that sometimes it's difficult to know that, hey, these guys over here, they got this new fancy way with their instrumentation that has a hot spare out of the other 7 channels, and if any one of those goes out, it'll grab that one as a hot spare. I was just like, oh, wow, I've never thought of that. That's what I said.
Okay.
I'll add a couple things. In my business of model predictive control, the process knowledge I'm finding more and more is the key to getting these applications done correctly. And I spend a lot of time with the site person like Michael, but also I spend a lot of time with the process expert and trying to understand the process, understand the problem from almost from a theoretical standpoint. The other thing is data is very common. You saw the pie charts that Michael had. We have with similar charts from 1-minute data going back for many, many years. You can go back and analyze that. You can find a lot of information from that. There's no automated tool yet to do that. It's been promised about 20 or 30 years ago there was a tool that was around. But no, there still is nothing good, but if you have with a good process knowledge and you can go back through that, that's a great resource to have. And the other thing is connectivity right now. I can connect to all the sites within the ExxonMobil framework, sign on and actually analyze and troubleshoot and help the site folks. So that's become a key thing as well. And And it's a great thing, particularly as we continue to be more security conscious. Being inside the walls, allowing me to be able to go in and assist the sites and troubleshooting problems that come up.
Absolutely. There was many times when I'd be at home or on the road traveling, I log in and kind of step the operator through. This is what's going on. This is what you can do to get through the problem. Yeah.
So I think we're just about out of time. If there are no more questions, I'm just going to wrap things up. But I hope you got a lot out of the session. And I think it's important that as you're looking at your own energy management programs, there's things that you can do today. We think it's important that you start small and develop a center of excellence, and you can look at many areas. And back to the original slide that I had put up, looking at furnace O2 optimization, exchanger cleaning programs, optimization of steam letdown stations. There's things that you can be doing today, and there's technology that can help you with your programs. So if you could just join me and give the team a hand, and we think you did a good job. So thanks very much, and thank you.